So welcome. In this session, we are going to look at the histology of the cerebellum. This is the cerebellum. Okay, it is folded. You can see the cortex is folded to form folia. Then you can see the white matter. This is the white matter here. The white matter forms a tree-like pattern. The cerebellum, which is known as the above vitae cerebelli. Above vitae cerebelli. Maybe I should write that the above vitae cerebelli. So that is the tree-like pattern formed by the white matter. Okay. Away from that, let me remove this so that you can see. Okay. So here we can see the cerebellum. We will look at the histological organization of the cerebellar cortex. So it is made up of 3 layers. Let's see the. Maybe I should start with 10x. I want you to see a good section, clear one. Okay. So, sorry for the delay. It is clearing up very slowly. I don't know why. So, here you can see 3 layers from here up to here. Then we have this, a very small. Then we have this. Then this is the white matter here. This is the white matter. Then there is this up to there. Then we can see a single layer here of these are the Purkinje cells. We will discuss them. Then this is the outer molecular layer. So let's start with the outer molecular layer. So the outer molecular layer, it has numerous dendritic arborization of the Purkinje cells. It has very few cells, but we have the basket cells. It's hard to show you the basket cells. You have to believe there is basket cells and some sterate cells. So the outer molecular layer is mainly composed of the dendritic arborization of the Purkinje cells with a few basket and sterate cells. Also, in the molecular layer, outer molecular layer is the synapse between the climbing fibers with the dendrites of the Purkinje cells. Okay, so climbing fibers originate from the olivocerebellar pathway, and the para-olivocerebellar pathway. Olivocerebellar pathway originates from the olivary nucleus to the cerebellum. Para-olivocerebellar pathway originates from the accessory inferior olivary nucleus to the cerebellum. So let's look at the Purkinje cell layer. So the Purkinje cells, you should know the Purkinje cells, how they look. Maybe we should do a higher magnification than that. So this is a Purkinje cell. This is a very good Purkinje cell here. Also, this is a Purkinje cell. A Purkinje cell is usually a flask. You remember the volumetric flask? It is flask shaped. Its dendrites arise from the neck and pass into the molecular layer. This is the outer molecular layer. Now, this layer made up of Purkinje cell is the Purkinje cell layer. So dendrites arise from the neck of the flask, pass upward into the molecular layer, where it undergoes profuse branching, the dendritic arborization. So the axon, so the dendrites go to the molecular layer. Then the axon axons usually pass into the intracerebellar nuclei. The intracerebellar nuclei are like the dentate nucleus, embodiform nucleus, fastigial nucleus. Which other nucleus? I have forgotten one, cannot remember one, but there are usually 4 intracerebellar nuclei. So, and the axons of the Purkinje cells are the only output of the cerebellar cortex. Okay, they are the only output. So they send their dendrites into the molecular layer, where they synapse with the climbing fibers. They will also synapse with the axons from the granule cells. We will look at that. Then they send their axons into the intracerebellar nuclei, the 4 of them. I've forgotten one, sorry for that. Then we have the granular layer. The granular layer is this one. You can see it is somewhat granular. As to see, it consists of mainly granule cells and Golgi cells. Okay, they are dendrites from the granule cells usually synapse with the mossy fibers. Mossy, maybe I should write also mossy fibers. Let me do it here. Mossy fibers. Mossy fibers, they usually arise from all fibers or pathways that terminate into the cerebellum, except the olivocerebellar pathway and para-olivocerebellar pathway. So pathways such as the cuneo-cerebellar, they usually terminate into mossy fibers. Pathways such as the pontocerebellar pathway usually terminate in mossy fibers, and they synapse with the dendrites of the granule cell. Then the granule cells usually sends its axon towards the molecular layer, and which usually bifurcates at the molecular layer. It usually bifurcates to form a T junction. So it is one, say one here, then it bifurcates like this and like this. So an axon then forms a T junction, bifurcates to that direction and also to that direction, and it will synapse with the dendrites of the Purkinje cells. That is why I've said the Purkinje axon is the sole output of the cerebellar cortex. So we have the intracerebellar nuclei. I've said there is dentate, embodiform. There is also the fastigial, or the other one was globosas. I've remembered it, globosas. Remember, the dentate nucleus is associated with the neocerebellum. Then the embodiform and the globosas, they are associated with the paleocerebellum. Then nucleus fastigial is associated with the achy-cerebellum. Okay, so that is the histological organization of the cerebellar cortex. An overview: we have outer molecular, a Purkinje cell layer, then inner granular. Cell types here are the sterate and the basket cells, but it has numerous dendritic arborization of the Purkinje cells, Purkinje cell layer. Then the inner granular layer has granule cell and few Golgi cells. I've said the dendrites of the granule cell usually synapse with the mossy fibers. Then it sends an axon to the molecular layer, which bifurcates to synapse with the dendrites of the Purkinje cells, then the Purkinje cell sends an axon to the intracerebellar nuclei. Only the climbing fibers from the olivocerebellar and para-olivocerebellar pathways usually terminate in the molecular layer. With that, I would like to say thank you, and you have come to the end of that session. Please subscribe for more.